The Planetary Defense, protecting Earth from Asteriod impacts for space. Hello, everyone. Welcome to Space Explorer channel. Asteroids are small celestial bodies that orbit the Sun and can pose a major threat to life on Earth. It is important to understand the potential risks of asteroid impacts and how to protect our planet from them. This video will discuss the Planetary Defense System, a strategy used to detect and respond to potentially hazardous asteroids in order to protect the Earth from their impacts. We will examine how the Planetary Defense System works and discuss how it can be used to safeguard our planet from dangerous asteroids. Before moving forward, if you are new to our channel, please don't forget to like and subscribe our channel for future interesting videos. The threat of asteroid impacts on Earth. Asteroid impacts pose a serious threat to life on Earth. These celestial bodies, ranging in size from small rocks to massive boulders, can cause catastrophic damage upon impact. While the chances of a catastrophic asteroid impact are relatively low, the potential consequences are so severe that it is essential to understand and address this threat. The threat of asteroid impacts on Earth has been a subject of concern for scientists and astronomers for many years. The history of our planet is marked by several notable impacts, the most famous being the event that led to the extinction of the dinosaurs. The impact of an asteroid, estimated to be about 10 kilometers in diameter, caused a global catastrophe that wiped out 3/4 of all plant and animal species on Earth. This event serves as a stark reminder of the devastating power of asteroid impacts. In recent years, there has been an increased focus on the search for near-Earth asteroids, NEAs. These are asteroids whose orbits bring them close to our planet. Detecting and tracking these objects is crucial for developing effective strategies to mitigate the impact threat they pose. NASA's Near-Earth Object Observations, NEOO program, along with other international efforts, actively searches for and monitors these potentially hazardous asteroids. Identifying potential impact events is a challenging task that requires continuous monitoring and analysis of the trajectory and characteristics of near-Earth asteroids. Scientists use a combination of ground-based and space-based telescopes to observe and track these objects. By carefully studying their size, composition, and orbit, experts can assess the risk of an impact event and determine if any action needs to be taken. Deflecting an asteroid is a complex task that requires advanced technologies and innovative strategies. Current approaches include techniques such as kinetic impactors and gravity tractors, which aim to alter the course of an asteroid to prevent a collision with Earth. However, these technologies are still being developed and tested, and there are significant challenges to overcome before they can be deployed effectively. Addressing the threat of asteroid impacts requires collaborative international efforts. Organizations such as NASA and the European Space Agency work together to share data, resources, and expertise. Additionally, international agreements and protocols have been established to facilitate coordination and cooperation in the event of a potential impact. The future of planetary defense technology holds great promise. Advancements in space-based telescopes, artificial intelligence, and propulsion systems are enabling scientists to better detect and characterize asteroids. With continued investment and research, we can enhance our ability to protect Earth from the threat of asteroid impacts and ensure the long-term safety of our planet. One promising area of research is the development of early warning systems that can provide advance notice of potential impact events. These systems would give scientists and authorities more time to assess the threat and take appropriate actions, such as evacuations or deployment of deflection technologies. Additionally, there are ongoing efforts to improve our understanding of the behavior and composition of asteroids, as this information is crucial for determining the most effective deflection strategies. Collaborative initiatives between space agencies and private companies are also exploring the possibility of asteroid mining, which could not only provide valuable resources, but also help to reduce the overall number of potential impactors by redirecting them away from Earth. The threat of asteroid impacts is real, but with continued dedication and cooperation, we can strive to minimize the risks and ensure the safety of our planet for future generations. The history of asteroid impacts on Earth. Throughout the history of Earth, there have been several significant asteroid impacts that have left a lasting impact on our planet. These events serve as a chilling reminder of the potential devastation that can be caused by these celestial objects. One of the most famous asteroid impacts in history occurred approximately 65 million years ago. This event is widely believed to have led to the extinction of the dinosaurs. The impact of an asteroid, estimated to be about 10 kilometers in diameter, caused widespread destruction and triggered massive fires and tsunamis. The resulting debris and dust clouded the atmosphere, leading to a global climate change that ultimately wiped out 3/4 of all plant and animal species on Earth. This cataclysmic event reshaped the course of life on our planet. Another notable asteroid impact occurred in Tunguska, Siberia, in 1908. Although no human lives were lost in this event, the explosion flattened trees over an area of about 800 square miles. The blast, which is estimated to have been 1,000 times more powerful than the atomic bomb dropped on Hiroshima, serves as a reminder of the potential devastation that can occur from even smaller asteroid impacts. These historical impacts have provided scientists with valuable insight into the power and consequences of asteroid collisions. By studying the aftermath of these events, researchers have been able to develop models and simulations to better understand the potential effects of future impacts. This knowledge is crucial for developing effective strategies to mitigate the impact threat. In recent years, there has been an increased focus on detecting and monitoring near-Earth asteroids, NEAs, that pose a potential threat to our planet. Advances in technology, such as ground-based and space-based telescopes, have allowed scientists to track these objects more effectively. By studying their size, composition, and orbit, experts can assess the risk of an impact event and take appropriate action to protect Earth. The history of asteroid impacts on Earth is a sobering reminder of the potential consequences of these celestial objects. By understanding the history and developing advanced technologies and strategies, we can better prepare for the future and ensure the long-term safety of our planet. With continued collaboration and research, we can work towards a future where the threat of asteroid impacts is effectively mitigated, safeguarding life on Earth for generations to come. One way scientists are working to mitigate the impact threat is through the development of asteroid deflection techniques. These methods involve altering the course of an incoming asteroid to divert it away from Earth's path. Proposed techniques include kinetic impactors, where a spacecraft would collide with the asteroid to change its trajectory, and gravity tractors, which would use the gravitational force of a spacecraft to gradually pull the asteroid off its course. In addition to deflection, early warning systems play a crucial role in protecting Earth from asteroid impacts. Organizations such as NASA's Near-Earth Object Observations Program constantly monitor the skies for potentially hazardous asteroids. By identifying and tracking these objects, scientists can provide advance notice and prepare contingency plans if a significant impact is predicted. Ultimately, the history of asteroid impacts on Earth serves as a reminder of our vulnerability to cosmic events. Through continued research, collaboration, and technological advancements, we can enhance our understanding and readiness to safeguard our planet from the potential devastation caused by these celestial objects. The search for near-Earth asteroids. As we've discussed, the threat of asteroid impacts on Earth is a serious concern. To protect our planet, it is crucial to actively search for and monitor near-Earth asteroids, NEAs. But how do scientists go about this daunting task? The search for near-Earth asteroids is a collaborative effort that involves ground-based and space-based telescopes, along with advanced technology and dedicated teams of scientists. These telescopes scan the night sky, carefully observing and tracking any celestial objects that come within a certain distance of Earth. One of the key players in this search is NASA's Near-Earth Object Observations, NEOBO program. This program is responsible for locating, tracking, and characterizing potentially hazardous asteroids. It operates a network of ground-based telescopes around the world, working in collaboration with other international organizations and agencies. Together, they strive to detect and track as many NEAs as possible in order to assess the potential risks they pose. In recent years, there have been significant advancements in technology that have greatly improved our ability to detect and track NEAs. Space-based telescopes, such as the Wide Field Infrared Survey Explorer, WISE, and the upcoming NEO Surveyor, have provided astronomers with a clearer and more comprehensive view of the night sky. These telescopes can detect asteroids that may be hidden from ground-based observations due to factors such as the brightness of nearby stars or atmospheric interference. Additionally, advancements in artificial intelligence have played a crucial role in the search for near-Earth asteroids. AI algorithms can analyze vast amounts of data from telescopes and quickly identify potential asteroid candidates. This helps astronomers to focus their efforts on objects that are most likely to pose a threat to Earth. The search for near-Earth asteroids is a continuous process, as new asteroids are discovered and existing ones are tracked over time. Scientists are constantly refining their methods and technologies to improve detection capabilities. The goal is to identify potentially hazardous asteroids well in advance, giving us ample time to develop and implement appropriate mitigation strategies. By understanding the characteristics and trajectories of NEAs, scientists can determine if any of them pose a potential threat to Earth in the future. This information allows for the development of mitigation strategies, such as deflecting or destroying the asteroid before it reaches our planet. NASA's Double Asteroid Redirection Test (DART) mission, scheduled for launch in 2021, will test one such strategy by intentionally crashing a spacecraft into a small asteroid to alter its orbit. This mission will provide valuable data and insights for future asteroid deflection efforts. In addition to detection and mitigation, the search for NEAs also provides valuable scientific knowledge. Studying these celestial objects can help us understand the early solar system and its formation. By analyzing the composition and structure of NEAs, scientists can learn more about the origins of Earth and other planets. Overall, the search for near-Earth asteroids is an essential task that requires ongoing collaboration, technological advancements, and a dedicated scientific community. With continued efforts and advancements, we can better protect our planet and gain valuable insights into the mysteries of our universe. Identifying potential impact events. Identifying potential impact events is a crucial task in the field of planetary defense. It involves continuously monitoring and analyzing the trajectory and characteristics of near-Earth asteroids to assess the risk of an impact event and determine if any action needs to be taken. So, how do scientists go about this challenging process? One of the key components of identifying potential impact events is the continuous tracking and observation of near-Earth asteroids, NEAs. Ground-based and space-based telescopes play a vital role in this process. By carefully observing these celestial objects, scientists can gather valuable data on their size, composition, and orbit. This information is essential for assessing the risk and predicting any potential impact on Earth. To improve our detection capabilities, scientists also use advanced modeling and simulation techniques. By creating computer models that simulate the motion of NEAs, researchers can predict their future trajectories and potential impact events. These models take into account various factors such as gravitational forces, orbital dynamics, and the influence of other celestial bodies. Through this process, scientists can identify potential impact events and estimate their severity. Another important aspect of identifying potential impact events is the continuous refinement of detection methods and technologies. Scientists are constantly improving their observational techniques to detect smaller and fainter asteroids that may pose a threat to Earth. This includes the use of advanced telescopes, such as the upcoming NEO Surveyor, which will provide a clearer and more comprehensive view of the night sky. Additionally, Collaborations and data sharing among international organizations and agencies play a crucial role in identifying potential impact events. Organizations like NASA and the European Space Agency work together to share resources and expertise. International agreements and protocols have been established to facilitate coordination in the event of a potential impact. This collaborative approach enhances our ability to detect and respond to potential threats effectively. Identifying potential impact events is an ongoing process that requires constant vigilance and advancement in technology. By combining observation, modeling, and collaboration, scientists are continuously improving our ability to identify and mitigate the threat of asteroid impacts. The more we learn about these celestial objects, the better prepared we can be to safeguard our planet and ensure the long-term safety of humanity. New technologies, such as the use of artificial intelligence and machine learning, are also being explored to improve the identification of potential impact events. These advancements can aid in the automated analysis of large data sets, allowing scientists to quickly identify and track near-Earth asteroids. Additionally, efforts are being made to develop early warning systems that can alert us to potential threats with enough time to take necessary action. Furthermore, international efforts are underway to develop and test planetary defense strategies. These strategies include concepts such as asteroid deflection missions, which aim to alter the trajectory of an incoming asteroid to prevent a collision with Earth. Collaborative projects like the Asteroid Impact and Deflection Assessment (AIDA) mission, a joint effort between NASA and the European Space Agency, are working towards validating these techniques. Deflecting an asteroid. Current technologies and challenges. Deflecting an asteroid is a complex and challenging task that requires advanced technologies and innovative strategies. While the concept of diverting an asteroid from its path to prevent a collision with Earth may seem like the stuff of science fiction, scientists and researchers are actively working on developing practical and effective methods to protect our planet from this potential threat. One of the current technologies being explored for asteroid deflection is kinetic impactors. This approach involves deliberately crashing a spacecraft into an asteroid to alter its course. By delivering a high-speed impact, the spacecraft can change the momentum of the asteroid, causing it to deviate from its original trajectory. This method relies on precise calculations and understanding of the asteroid's composition and structure to ensure a successful deflection. Another technique being investigated is the use of gravity tractors. This concept involves positioning a spacecraft near an asteroid and allowing the mutual gravitational attraction between the two to gradually alter the asteroid's path. The spacecraft acts as a gravitational anchor, exerting a gentle but persistent tug on the asteroid over an extended period. This method requires careful planning and coordination to ensure the spacecraft remains near the asteroid for an extended period. While these technologies hold great promise, several challenges need to be addressed. One of the main challenges is identifying and tracking potentially hazardous asteroids well in advance. Detecting these objects early is crucial to provide sufficient time for deflection strategies to be implemented. Current detection capabilities are constantly being improved, but there is still much work to be done to achieve comprehensive coverage and accurate tracking. Another challenge is developing the necessary spacecraft and mission architectures to carry out asteroid deflection missions. These missions require spacecraft capable of reaching high speeds and delivering precise impacts. Additionally, long-duration missions are necessary for gravity tractors to be effective, which presents additional technical and logistical challenges. Collaboration and international cooperation are also essential in overcoming these challenges. Organizations such as NASA, the European Space Agency, and other international space agencies are working together to share resources, expertise, and data. This collaboration enables the pooling of knowledge and resources, accelerating progress and improving the chances of successfully deflecting asteroids. In addition to the technical and logistical challenges, there are also ethical considerations to be taken into account when it comes to asteroid deflection. Some experts argue that altering the course of an asteroid could potentially have unintended consequences, such as sending it on a collision course with another celestial body or disrupting the delicate balance of the solar system. These concerns highlight the need for thorough risk assessments and careful decision-making processes in any asteroid deflection mission. Furthermore, public awareness and engagement are crucial in addressing the challenges of asteroid deflection. Educating the public about the potential risks and the ongoing efforts to protect Earth from asteroids can help generate support and funding for research and development in this field. It is important to foster a sense of shared responsibility and encourage individuals and communities to actively participate in efforts to detect and mitigate potential asteroid threats. Collaborative international efforts to protect Earth. Collaborative international efforts play a crucial role in protecting Earth from the threat of asteroid impacts. Given the global nature of this potential disaster, it is essential for nations and organizations to work together to ensure the long-term safety of our planet. Organizations such as NASA, the European Space Agency, ESA, and other international space agencies actively collaborate to share resources, expertise, and data. This collaboration is vital in pooling knowledge and advancing our understanding of near-Earth asteroids, NEAs. By working together, scientists and researchers can develop more accurate models and simulations, improving our ability to detect and mitigate the impact threat. International agreements and protocols have also been established to facilitate coordination in the event of a potential impact. These agreements outline guidelines for sharing information, coordinating observations, and collaborating on deflection strategies. This unified approach ensures that everyone is on the same page and can effectively respond to any potential threat. The sharing of data is particularly important in the search for near-Earth asteroids. By combining resources and observations from various telescopes and space missions, scientists can gain a comprehensive understanding of the potential risks. This collaborative data sharing enables researchers to track and monitor NEAs more effectively, identifying potential impact events well in advance. The future of planetary defense technology. The future of planetary defense technology holds great promise in the ongoing efforts to protect Earth from asteroid impacts. Advancements in various fields, including space-based telescopes, artificial intelligence, and propulsion systems, are paving the way for innovative strategies to detect, track, and mitigate the impact threat. Space-based telescopes, such as the upcoming NEO Surveyor, are revolutionizing our ability to detect and monitor near-Earth asteroids, NEAs. These advanced telescopes provide a clearer and more comprehensive view of the night sky, allowing scientists to identify and track potentially hazardous asteroids more effectively. By continuously improving our detection capabilities, we can identify these objects well in advance, giving us ample time to develop and implement appropriate mitigation strategies. In addition, advancements in propulsion systems are enabling scientists to explore innovative strategies for asteroid deflection. Current technologies, such as kinetic impactors and gravity tractors, are being refined and tested to ensure their effectiveness in diverting asteroids away from Earth. As we continue to develop and improve these technologies, we increase our chances of successfully protecting our planet from the devastating impact of asteroids. Furthermore, ongoing international collaboration and cooperation are vital for the future of planetary defense technology. Organizations like NASA, the European Space Agency, and other international space agencies are working together to share resources, expertise, and data. By combining our efforts and knowledge, we can accelerate progress and enhance our ability to detect, track, and mitigate the impact threat. In conclusion, the future of planetary defense technology holds great promise in safeguarding Earth from the threat of asteroid impacts. Advancements in space-based telescopes, AI, propulsion systems, and international collaboration are revolutionizing our ability to detect, track, and deflect potentially hazardous asteroids. With continued investment and research, we can ensure the long-term safety of our planet and protect future generations from the devastating consequences of asteroid impacts. If you enjoyed from this video, please don't forget to like and subscribe our channel for future interesting videos. Thanks for watching.